OCR Maths and Stats Differentiation. In the following series of videos, I will cover the differentiation techniques used in AS Maths and then move on to the more advanced techniques for differentiation used in Core 3 and Core 4. Differentiating x to the power of n. Y is equal to 2x to the power of 5. So dy by dx is equal to 2. And then if we differentiate x to the power of 5, we get 5x to the power of 4. So simplifying, we have 10x to the power of 4. Differentiate, so d by dx, 2x to the power of 5. And that gives us 2. And then differentiating x to the power of 5, 5x to the power of 4, so 10x to the power of 4. D by dx is just an operator that's telling you to differentiate with respect to x. So whatever follows d by dx, so in this case 2x to the power of 5, it's just telling you to differentiate 2x to the power of 5, and you're differentiating with respect to x. Differentiating minus 5 times the cube root of x. The cube root of x in index form is x to the power of a third. Differentiating gives us minus 5 from here. The 1/3 comes to the front, times x to the power of, and we have to subtract 1 from the original power, so 1/3 minus 1 to give minus 2/3, and then simplifying. Differentiating x squared plus e times x. So both of these terms will be differentiated because they're in brackets. Okay, differentiating x squared gives 2x. Differentiating e times x will give us e. Ex is just similar to differentiating, let's say, d by dx 3x. Yeah, it's just a constant, e is just a constant times x. Like this here, 3 is a constant times x. And if you differentiate 3x, you just get 3. So if you differentiate ex, you get e. This example is similar to the last one, except I've removed the brackets. So this time, only the x squared is differentiated and not the ex. Okay, so differentiating x squared gives 2x. We're not doing anything to the ex, so we just add on ex. If the ex was going to be differentiated, then we should either have started off like this, so using brackets, or we should have had differentiate x squared plus differentiate ex. And be careful how you read the notation here. It's e times x, it's not this. Differentiating 1 over 4x. This is not the same as differentiating 4x to the power of minus 1. This is wrong. You can see a quarter here, but now we've changed that incorrectly to 4, so this is wrong. We're going to differentiate a quarter times x to the power of minus 1. So we have a quarter. The minus 1 comes to the front, like this, times x to the power of, and if we subtract 1 from the original power, we get this, and then we can simplify to minus a quarter x to the power of minus 2, and if we want, if it's useful, we could write this as minus 1 over 4x squared.